Let's get to work building a button box. I've set up a small workstation to be able to build this box. I often get a lot of questions about how I was able to build my cockpit. And although I'm not going to go through the process of building another one at this point, I can use a button box to demonstrate some of the techniques I used to build the cockpit. This build is going to be broken down into several videos. It felt right to make sections as I work through it. So if you don't want to miss anything, please don't forget to subscribe so you know when they're out right away. Let's start with tools and materials required. While a more modern method might involve using a 3D printer, I prefer to use a little bit of an old school method. Primarily, this doesn't involve using a lot of tools, and our main building material is using sheet styrene, or sometimes known as plastic hard. It can be marked with simple tools, scored with a knife, and be broken into any shapes that you desire. The major advantage here is really only requiring a knife, and parts can be cemented together to form complex structures. Here are some examples of components I constructed for my cockpit. These were used to mount the MFDs. And here's a look at the center console. This is the housing for the trackball. And here's a look of the targeting computer before the components were installed. Here's a good look at every panel, box, and other piece of equipment I built for the cockpit. And as a last step, they were mounted to the wooden frame that made up the rest of the cockpit. As you can see, there's a lot of flexibility. For this build, we're going to be using an Arduino Mega. These devices can be used for many different electronics projects, but in our case, we can turn them into a USB controller. They're relatively inexpensive, and they give us the option of pre-processing the input before turning it into USB input that the computer interprets. The most important thing in getting one of these Arduinos to make sure it supports DFU mode. Some clones don't offer this function, and being able to use it is what allows us to convert it to a USB controller. Being able to pre-process the input is exactly how I get features like the landing gear lights and autopilot panel to work in my cockpit. In addition to the Arduino, we'll also need some switches to interact with it that's going to generate our input. We can use illuminated or non-illuminated switches. The Arduino is able to provide power to light up these switches. It's important to have these buttons and switches at the start of the project to ensure we're creating the right size mounting holes for them. We can also use toggles or momentary buttons. And for this build, we'll also be using digital encoders. It's also helpful to have a breadboard in order to connect all the components together. And the breadboard is also useful for testing before we completely solder everything together. Plastic card comes in different sizes and different thicknesses. For building a button box, I recommend 0.125 inches, but thinner sheets can also be used for detail or for small cutouts. This provides a good balance of stability and still making it easy enough to score and break off the pieces that you need. It's also possible to cement multiple layers of plastic card together in order to form a thicker structure. So we can use this to build up additional details. The most valuable tools during the entire build process are a sharp knife and a digital caliper. Additionally, I have a large cutting mat that makes measuring and cutting just a little bit easier. The caliper is an extremely useful tool during this entire process because it can be used to quickly make an initial mark on the plastic card, which can be then followed up with the knife to score and then break off the pieces that we need. It can also be used to quickly measure and then used as an aid to mark out and duplicate parts. And it can be used to measure existing devices you want to match the dimensions of. Because there will sometimes be gaps, we can use an epoxy putty like Milliput to fill in those gaps. The two parts can be mixed together, and once set, it's basically as hard as a rock. and can be sanded, filed, or drilled. A set of pliers and clippers are also useful for manipulating the plastic card. Let's get into building. The first thing we need to do is create a way of mounting the Arduino Mega to the plastic card. Here I've already cut a piece of plastic card roughly to size and drilled out holes to put in nylon screws, nuts, and standoffs. The holes were made by simply placing the Arduino on top of the plastic card, then marking them with a pencil, and then drilling them out. This ensures that everything's aligned. I then attach the nylon standoffs through the plastic card by pushing them through and attaching them with the nuts. If you've ever built your own computer, this is basically the same idea as putting the standoffs in your case and mounting your motherboard. With the standoffs in place, I then used nylon screws to secure the Arduino Mega to the standoffs. Now that we have the Arduino mounted, we want to make sure that when we're constructing the rest of the box, that we're leaving enough space for all the components. So I've laid out the breadboard and the Arduino to make sure I'm leaving enough room. Next, we mark the plastic card where we want to cut, score with the knife, and then break off the piece. This will form the base for the button box. Here I've used a couple of pieces of plastic card and attached them to the bottom of our mount for the Mega so that we can attach it to the base of the button box. Using the lines on the cutting mat as a guide, I roughly find the center point for the USB port on the Arduino Mega, and then mark on the plastic card base where I want this to end up. I then apply some plastic cement in order to attach the pieces together. Plastic cement takes about 30 seconds to melt both pieces together and provide a good bond. After only a short amount of time, the pieces are permanently attached. We're now going to take a look at building up the sides of the button box. Planning on using some illuminated toggle switches along a raised section, so I want to make sure I'm leaving enough clearance when I'm planning it out. The top section is going to be sloped, so using those toggle switches as a guide, I've marked off where roughly I need to make the cuts. I've scored the plastic card with the knife and then broken off the pieces. You can see how it lines up and creates one side of the box. Of course, we'll have to duplicate it in order to make the other side. I set the caliper to the measurements of the first piece and lock it in place. I can then use the caliper to make a marking on another piece of plastic card by dragging one side against the edge of the plastic and pressing the other side in against the flat part of the plastic. Here, I'm tracing it out with pencil to make it more visible. I can get a straight line by pencil at this point because the pencil rests within a groove that's created by rubbing the caliper against the plastic. I've scored through the plastic with the knife at this point, but where there's not a lot left to get any leverage on to break, it's sometimes useful to use pliers to help break off that piece. I then use the caliper to measure and mark the other dimensions of the piece that I'm creating. Double checking to make sure that everything lines up, I'm then able to cut through the plastic. Sometimes you don't get a clean break when scoring and cutting the plastic. In that case, you can just use the knife to help clean up. Later on, we can also fill in with Milliput if required. But at this stage, don't worry about perfection. With the left and right hand side pieces of the box cut into their initial shapes, I begin planning on putting in some rotary encoders on each of the sides. Like planning for the toggle switches, I'm making sure I'm leaving enough room not just for the rotary encoder itself, but for the knobs that rest on them. I've marked the centers of where I want the rotary encoders to go. I find the easiest way to make sure that you're drilling the right size hole is to use the caliper to measure the switch, button, or rotary encoder that you want to use, and then finding the drill bit that is closest to it. If you don't have a drill bit that's an exact match, use one that is slightly larger than the distance that you measured for the switch, button, or rotary encoder. You can verify this by using the measurement you took with a digital caliper. Using a scrap piece of wood, I can drill down through the plastic card to make the hole for the rotary encoder. Be careful when drilling plastic card, as it won't drill like wood. The plastic has a tendency to catch the drill bit, so it'll either lift up or might get pulled away from you while drilling. A duller drill bit will actually work a little bit better because it will have a tendency to not get caught up in the plastic as easily. Above all, go slow. Both side pieces are now complete, but we want to take the rotary encoders and test fit them to ensure that everything is working out. Rotary encoders have a small metal tab near the base. This metal tab can be used to stop the rotary encoder from rotating. The rotary encoder spins and clicks and acts much like a mouse wheel. So using this metal tab, we can indent the plastic. So using the holes that I've drilled in each of the sides, I press the rotary encoder, including the tab, against the plastic to mark gently. I can then make a more permanent mark with another tool. This can be done with using a knife to dig out a small trench, or by pressing firmly with a straight screwdriver. Finally, we can test fit the rotary encoder by using the nut and washer that comes with it and placing on the knob. You can see here how it will look once this piece is attached to the base. There's also a small gap between the top of the slanted section and the edge of the knob, which will allow it to be spun around easier. Here's a closer look at the mounts for the rotary encoders. With the side pieces complete, we can use a pre-formed piece of plastic card in the shape of an L that we can use to make a right angle to attach the side pieces to the base. While not necessary, the L-shaped pieces do make attaching the sides a little bit easier. These pieces can be cut and broken the same way as a regular sheet of plastic card. Next, we can use some cement to attach all the pieces together. Try to keep things as lined up as possible, although we don't need to be super precise. Using a similar method, we can also create a front piece for the box. Now we want to check to make sure that we have enough clearance to add the toggle switches along the top slanted row. Because the rotary encoders take up some of the space, we need to account for that gap. We'll also need to cut a new piece of plastic card to fit on top. Once again, we can use the caliper to take the measurements and then make the initial marking on the plastic card. Then we can score and break as usual. The piece I cut here is the right height, and now we just have to trim the length. I've cut out a smaller piece that will add stability to the larger piece and will act as a guide for mounting the toggle switches. Here I'm using it to check the location that I want the toggle switches to end up to ensure there's enough room for the rotary encoders. Once verified, I mark the edge with a pencil so I can place it back in that location when done. Next, we can measure the size of the toggle switches using the caliper and then use the closest drill bit to drill out the holes. By limiting ourselves to the small piece of plastic, we won't have ruined the large piece should we make any mistakes. Next, we can test fit the toggle switches to ensure that they fit within the holes that we've created. Don't worry about making sure that they're perfectly aligned or all the nuts have the same orientation at this point. Just make sure that there's enough clearance so that when we go to attach them, we won't run into any issues. In order to make things a little more visually interesting, I'm chopping off the corners after measuring and marking them. Once again, it's a good idea to use pliers where there's not much leverage to break off these tiny pieces. Next, we're going to add another rotary encoder to this top slanted section, following the same methods as before. I'm creating another plate for additional support and stability, roughly matching the size of the encoder and the other row of switches. Next, I'm adding a couple of cutouts from scrap pieces of plastic card to create some additional support for the top row of switches. I've also added another strip along the top to fill in the top part of the box. I've also added some small strips along the top slanted section inside to provide some better stability. Using the same methods, I've also created a basic top piece This will end part 1 in this series. Next time, we'll finish off the construction of the physical box. In future videos, we'll move on to wiring everything up, and then finally, programming the button box. If you like this video, please give it a like, let me know in the comments, and share with your friends. Also, if you have any questions, leave them in the comments below, and don't forget to subscribe so you know when the next parts to this video are out. Thank you for the support.